Yeah, good morning. Yeah, we continue with our study on trigonometry. Yeah, and this morning, before we dive deep into trigonometry, I want us to just look at a brief overview or a brief recap on some of the important concepts in trigonometry. So let us first start by looking at what we call quadrants. Now, let us start by looking at what we call quadrants. Now, these quadrants are associated with the x or y plane. These quadrants are associated with the x or y plane. And basically, we have got four quadrants. Basically, in trigonometry, we have got four quadrants, and these quadrants are associated with the x or y plane. So we can have an x or y plane so that I can help you understand what these quadrants are all about. Okay. So this is the y and this is the x. So now this is the first quadrant. This is the second quadrant. This is the third quadrant, and this is the fourth quadrant. Now, the first quadrant is between 0 degrees and 90 degrees. The second quadrant is between 90 degrees and 180 degrees. And the third quadrant is between 180 and 270 degrees. And the fourth quadrant is between 270 and 360 degrees. Now, the way each trig function behaves in this quadrant differs. The way each trig function behaves in this quadrant differs. And we have got three basic trig functions, and these are the basic trig functions are, we can say, basic trig function. The basic trig functions are, we have got the sine theta, the cos theta, and the tan theta. Okay, these are the basic trig functions that we have. Now, these basic trig functions also have their reciprocals. These basic trig functions also have their reciprocals. So the reciprocal of these basic trig functions are, we can talk of the reciprocals now. The reciprocals of trig. Functions. Okay, so the reciprocals of the basic trig functions are, we can talk of one. We have cosecant theta, which is abbreviated as cosec theta. 2, we have got secant, which is abbreviated as sec theta. Then 3, we have got cotangent, which is abbreviated as what? Cot theta. Okay, so now we need to understand that cosec theta is equals to 1 over sine of theta. Then secant theta is equals to 1 over cos theta, and cot theta is equals to 1 over tan of theta, which is the same as saying cos over sine of what? Of theta. So these are the reciprocal of the basic trig functions that we highlighted above. Now, it is important to note that the way each trig function and its reciprocal behaves in each quadrant differs. It is important to note that the way each trig function and its reciprocal behaves in each quadrant differs. So we can talk of the first quadrant, the first, second, third, and fourth quadrant. So let us quickly run through all these 4 quadrants. So we start the first quadrant. In the first quadrant, all the trig functions are positive. So we talk of when we talk all the trig function, we are simply talking about everything, including their reciprocals, are positive in the first quadrant. Then we go to the second quadrant. Here, only sine and its reciprocal is positive. Only sine and its reciprocal is positive. The rest are what? Are negative in the second quadrant. Then we go in the third quadrant. In the third quadrant, only tan and its reciprocal is positive. The rest are what? Are negative in the third quadrant. Then last we can look at the fourth quadrant. So in the fourth quadrant, only cos and its reciprocal is positive. The rest are what? The rest are negative. So now, to help us understand everything that we have, written from the first to the fourth quadrant, we have got a memory head that helps us remember these things in case we have forgotten. And our memory head is we can say 1, add sugar to coffee. Add sugar to coffee. So this is the first quadrant. This is the second quadrant. This is the third quadrant, and this is the fourth quadrant. So here the A stands for O. Here the sugar stands for sine and its reciprocal. Here the T stands for tan and its reciprocal. Here the C stands for cos and its reciprocal. So meaning that in the first quadrant all are positive. In the second quadrant only sine and its reciprocal are positive. In the third only tan and its reciprocal are positive. And in the fourth only cos and its reciprocal are positive. Okay. Then we can also look at the issue of reference angles. It is very much important because these reference angles, they help us they help us when it comes to solving trig equations. So it's very much important to also understand the concept of reference angles. So we can look at reference angles. Okay, let me just write that properly. So reference angles. So these reference angles we usually denote them by the symbol alpha. These reference angles are usually denoted by the symbol alpha. These reference angles are usually denoted by the symbol alpha. Now, what is a reference angle? Let us define it. Definition. So, a reference angle is an acute angle formed between the terminal side of the line segment and the x-axis. So this is an acute angle formed between the terminal side of the line segment and the x-axis. We call that the reference angle. So again, take note that the way you find the reference angle in each quadrant also differs. The way you find the reference angle in each quadrant also differs. Okay. So I think we'll start by the first, fourth. We'll start by the first, we go to the second, third, and fourth. Now, before we jump into that, I want you to understand the definition first, because we are saying to say this is an acute angle. Now, what is an acute angle? An acute angle is an angle between 0 and 90. So, meaning that the reference angle should always be between 0 and 90. It should not exceed 90, and it should not be less than what? 0. But it should be in between 0 and 90. Then that angle qualifies to be called a reference angle. So now let us look at now how you find the reference angle in the first quadrant. So in the first quadrant, comma, the reference angle is given by alpha is equals to what? Theta. That's the first quadrant, because anything that you have in the first quadrant, of course, because you need to say the first quadrant is between 0 and 90. So whatsoever you have in the first quadrant is less than 90 and is greater than what? 0. So you just get whatsoever angle you have in the first quadrant, and that becomes your reference angle. We go to the second quadrant. Then we can say in the second quadrant, comma, the reference angle is given by alpha is equals to 180 minus what? Minus theta. That is in the second quadrant. Then we go in the third quadrant. In the third quadrant, comma, the reference angle is given by alpha is equals to theta minus 180. Then we go lastly in the fourth quadrant. In the fourth quadrant, so in the fourth quadrant, comma, the reference angle is given by alpha is equals to 360 minus what? Minus theta. So this is how you find. So now it is, so you must commit these things to memory with when it comes to the first quadrant. You need to know how to find your reference angle in the first quadrant, second, third, and fourth. So you must commit these things to memory. Okay. Then before we look at one or two questions with regards to what we have covered, I think it is important for us to also talk about the Pythagorean identities. Let us look at the Pythagorean identities. Let us look at what we call the Pythagorean identities. Pythagorean. Identities. So in my other video, I will show you how to derive this Pythagorean identity. But now I just want you to know them by heart. For now, I just want you to commit them to memory or to know them by heart. But in another video, I think we will look at I will make a video to show you how this Pythagorean identity was derived or how it came about. So the Pythagorean identity that we have is this one. We have sine squared theta cos squared theta is equals to 1. So this is the major one. This is what we call the Pythagorean identity. Now, if you understand this one, which is the major one, we can play around with this one and create other identities. So the first identity, the first identity that we can create from the Pythagorean identity is, we can say, taking sine theta squared to the other side of the equation, comma, we get, so if we take sine theta to the other side of the equation, we get cos squared theta is equals to 1 minus sine squared theta. We can call this identity 2. This is identity 1. Then we can say again, taking cos squared theta to the other side, of the equation, we get, so if we take cos squared theta to the other side, we get sine squared theta is equals to 1 minus cos squared theta. We can call this equation what? Equation 3. Then we can say now, we can also come up with another one where we say dividing, because we have got our equation 1 there. So we can say dividing equation 1 by sine squared theta, comma, we get, so dividing equation 1 by sine squared theta, we get, so what is our equation 1? Our equation 1 is this one, sine squared theta plus cos squared theta is equals to 1. So if we divide throughout by sine squared theta, we get sine squared theta over cos squared theta, over, we're dividing by sine squared theta over sine squared theta, even here over sine squared theta. So we know to say sine squared and sine squared give us a 1 plus, then we know to say cos squared theta over sine squared theta, we know to say this is cot squared theta is equals to, and you know to say 1 over sine, which is the reciprocal of sine, is equals to cosecant squared theta. So this becomes equation what? Equation 4. Okay, then we can also say dividing, again we can say dividing equation 1 now by cos, because for us to have equation 4, we divided by sine. So now we can say dividing equation 1 by cos squared theta, comma, we get, so we are going to say sine squared theta plus cos squared theta is equals to 1. Then we divide the equation 1 by cos, so we say over cos squared theta over cos squared theta over cos squared theta. So sine and cos give us tan squared theta, then cos plus, then cos over cos, just this gives us 1 is equals to, then 1 over cos, this gives us sec squared theta, and we can call this equation 5. Okay, then we can also say in equation 1, taking cot to the other side. So so we can say in equation 4, in equation 4, comma, taking cot theta to the other side, we get, so if we take cot theta to the other side, which is this one in equation 4, the cot goes aside, so it becomes, we get cosec squared theta minus cot squared theta is equals to 1. And that becomes equation what? 6. Then we can say in equation 5, comma, taking tan squared theta to the taking tan squared theta to the other side, comma, we get, if we take tan squared theta to the other side, what do we get? That is in equation 5, we get sec squared theta minus tan squared theta is equals to 1. And this becomes equation what? 7. Then lastly, we can look at what we call compound identities. So now identities of the form sine alpha plus or negative beta and cos alpha plus or negative beta so identities of the form sine alpha plus or negative beta and cos alpha positive or negative beta are called compound identities. Now, it is important that these compound identities are committed to memory. So, the first compound identity that I want us to commit to memory is this one, which is sine alpha plus beta, and this one is equal to you say sine of alpha cos of beta plus the positive sign maintains, but you just reverse the order, so it becomes cos now of alpha sine of what? Sine of beta. So with sine, the compound identity of sine, what happens is that you maintain the sign, you just reverse the order. Just as the name is sine, what you do is that you maintain the sign and you just reverse the order. So we started with cos alpha, then cos beta, the sign maintains, then we reverse the order, we say cos of alpha sine of beta. So the other one is this one, the compound identity is this one too, which is sine alpha minus what? Beta. So the same thing, we maintain the sign, we just reverse the order. So we're going to start with, of course, sine alpha cos beta. You maintain the sign, but you just reverse the order. It becomes cos of alpha sine of what? Sine of beta. Okay. Then now we look at another compound identity, which is 3. where we are having cos of alpha plus beta, which is equals to, so with this one you change the sign, but first let me write it so that I explain it very well. So this becomes cos of alpha cos of beta, then if it is positive there the sign becomes minus sine of alpha sine of what? Sine of beta. So here you just change the sign, but the order, you know, the order is more of that, you know, of a trend, because the cos they follow each other and the sine they follow each other. But what you just reverse there, you just what you just change there, you just change the sign. Okay, so the cos that is the order, cos sine is the order, cos sine is the order there. But what you just do is that you change the sign. If the sign is positive, then your identity will have a negative there. Then here what happens is, we have got sine alpha plus, that means we already done with that one. We mean the other one is cos alpha minus what? Minus beta. So this one is equals to, we start cos alpha cos beta. Our sign is negative there, so here we have positive. Then sine of alpha sine of what? Of beta. So these are the compound identities. So I think for us to answer trig functions, it is very much important that we take note of everything that we have talked about here. So I think, yeah, in my next video now I will solve questions with regards to everything that we have looked at here. So in this video, please, I urge you to go through this content, understand these identities, understand quadrants, understand reciprocals, and understand also the concept of the reference angle. So if we can do that, then in our next video, I think when we start solving questions, looking at various examples from various papers, from various institutions, I think the concept that we have looked at here, that we have covered here, will help us, or come in handy a lot. So thank you. Have a blessed time.